Okay, let's make some measurements in our real world, see if they match our simulation and analytical worlds. Okay, we have R1, we have R5, and R3, and R4. Okay, we have our complete circuit here, and we're gonna start by measuring the input voltage. Okay, and for that we have a meter. Okay, and we're gonna set this meter to read voltage. Okay, and we're gonna turn it on. So we have as an input voltage we have 10.01 volts. Okay, so let's go ahead and measure the voltage drop across each element. Let's start with R1 and see what we have for R1. For R1 we have 4.80 volts. Okay, how about the voltage drop across both 250 ohm resistors? Let's see how much voltage drop we have there. 5.09 voltage drop. And last but not least, the voltage drop across our 1 mega ohm resistor is 5.15 volts. Okay, so that's measuring voltage. Now let's measure current. To measure current, what we do is we open the circuit. Okay, we don't measure across, we open the circuit in the branch that we are interested in measuring the current flow. Let's measure the current that flows through R1, and we need to set this to read current now. I'm gonna set it to the 20 milliamp range. Okay, so our reading says that we have 9.4 milliamps flowing through R1. Okay, now let's close the circuit again, and let's open the circuit in the branch that holds the 250 ohm resistor. Okay, and let's see what reading we get there. For that one we get 9.40 milliamps. Okay, and now let's measure the current that flows through our 1 mega ohm resistor. And that current is, we need to set this to the micro amp range. It's 5.1 microamps.